Hello everyone, welcome back to the channel. I am Nikhil Kumar. Have you ever deployed an application on Kubernetes manually using the kubectl apply command, generating a certificate here, creating a secret there, again and again? In my previous video, we did exactly that, deploying an Nginx application, generating a TLS certificates, creating a secrets and applying Ingress. But if I told you all that could be automated with just single Ansible playbook. Today I will show you how I automated the entire workflow, including a certificate creation using Ansible and the Kubernetes. And trust me, once you see this demo, you will never want to type the kubectl command again. So here's the real problem. In production environment, you don't deploy one or two applications. You deploy dozens. Every manual deployment introduces the risk of human error. Maybe you forgot our namespace, mismatch a certificate, or apply resources out of order. But automation fixes that. Ansible talks directly to Kubernetes through kubernetes.core collection and can even handle crypto operations like key and certificate generation using the community.crypto. That means the complete end-to-end lifecycle automation from deployment, certificate, secret, and ingress all in the one code. Alright, enough theory. Let's build this automation from the scratch. I am running this from my Kubernetes server node and the playbook executes locally, so there is no inventory needed for this particular demo. To follow along, you need to install these two collections. First is kubernetes.core and another is community.crypto. For that we can use a command ansible-galaxy collection install kubernetes.core and community.crypto. So it's installing the collections. So in my system it's already installed, so that's why I got a message that it's already installed. Another thing is that kubernetes.core internally use the Python library called Kubernetes. So for that we need to install that using the pip3. So this is already installed in my system, but you can use the pip3 install Kubernetes. So it will install the Kubernetes library in your system. So this enables Ansible to talk to your cluster and generate the TLS assets automatically. And if your kubectl is already configured, Ansible automatically uses the same config context, so there is no extra setup required for that. So in my system, I can easily run the kubectl get nodes command or kubectl get pods command. So I don't need to do any additional step for Ansible to use the kubectl command. Now let's jump into the heart of our automation, the playbook. So let me open the Ansible playbook first. So this is the one. So this is our Ansible playbook. It runs on the local host because all the action, that is key generation, templating, and the resource application happens from this node itself. So we start by defining the variables. The first is a cert common name. This is the server name, that is rk2-server. These variables will be used to generate the TLS certificates. As you can see, I am giving the certificate organization name, certificate dates, certificate key path, CRT path, and the CSR path. These make the playbook reusable and the dynamic. And if you want to deploy a new application tomorrow, you just need to change these or pass the new ones using the -e. That's the power of parameterization in the Ansible. The first task is to deploy the application. This works like the kubectl apply -f, but the difference is it's idempotent. Rerunning it won't duplicate the resources or throw any error. It ensures the desired state is maintained properly. And if you want to see this particular file, if I come out and if I open this file, so this is the exact same deployment manifest file which we used to run via the kubectl apply command. And same goes for the service one, because we have a service file here as well. So I have already created a manifest file for all the resources, whether it's deployment, service, ingress. This is the same ingress file. I'm already updating those information here. And as you can see, I am having one different file called jinja2 file, which will be used to dynamically update the values of the TLS certificate. No worries, I will explain you in a while. So let's get back to our playbook. So let me update the number here. So till here we understood that this is the task to deploy the Nginx application using the K8s module. After that, we are creating a resource called service for the Nginx application. So here as well, we are using the same service.yml manifest file here. It ensures our Nginx application is reachable within the cluster. So I'm creating a cluster IP resource in the manifest file. Now let's automate something you would normally do manually, generating the TLS certificate. So here it creates a secure private key only once. So rerunning won't overwrite it. It's fully idempotent. That's the power of Ansible. And then we are generating a CSR, that is a certificate signing request. This replaces the manual OpenSSL command, and it's fully automated, parameterized, and the reusable. Finally, we are generating the self-signed certificate. This issues a self-signed certificate valid for the number of days we defined in the variables. In the real-world setup, you can easily switch this to use Let's Encrypt or the internal CA provider. Now we got the certificates. Let's make the Kubernetes use them. So for that, we are using this module, that is the template module. This is where the Jinja 2 templating makes your playbook dynamic. It injects the latest file name directly into your secret definition. So even if the file names or the validity change, so there is no manual edits needed for that. So let me show you this file very quickly. So tls secret.yml.j2, that's the Jinja 2 file. And in this, you can see we are looking up the file. So dynamically, it updates the file here for the CRT and the key files. And it will also encode it into the base 64. Let's go back to our playbook now. So K8s app.yml, and let's go to the last. Once the template file got updated, the TLS CRT and the TLS key, we create a secret using the same file. So this is the same we just created here. So we are using the same file here to create a secret. And at last, we are creating an ingress for our Nginx application. So that's it. With these steps, we have automated everything from TLS generation, ingress exposure. Now let's see this automation in the action. For that, let me come out of this file and run the command Ansible-playbook and the playbook name. So it's gathering the facts first. We can disable it as well. First it's deployed the Nginx application, then it created a service, and here it's creating a private key, generating a CSR, generating the self-signed certificate using those, and here it updated those value into the Jinja 2 file. And here it created a secret, and at last it created a ingress for our Nginx application. So let's quickly verify this. So if I run the kubectl get secret, we can see the secret got created 28 seconds ago via Ansible. And if we see the ingress rule for that, so kubectl get ingress, we can see the ingress rule got created for port number 80 and the 443. It's been created 40 seconds ago. If I do ls here, so it generated the TLS CRT, SCSR and the key. And this is the file we just updated via Jinja 2 file. And if we go to the top, so this is the content of the file, which is base 64 encoded, and it's been updated dynamically by the Ansible. Now let's test this very quickly with the curl command http://rke2-server. This means that HTTPS redirection is working fine because HTTP is redirecting the traffic to the HTTPS. So let me run it with the HTTPS. So it's a self-signed certificate, that's why we got an error. So let me use the -k here, and it's working. Our Nginx application are accessible. With just one click, we fully deployed our application, including the generation of self-signed certificate, creating an ingress rule, updated those values dynamically without any manual effort. Now let's make this even more smarter. In the real DevOps setup, you will want to deploy multiple apps dynamically. You can easily pass values at the runtime. So for that, right now we have provided the information inside the playbook itself for the variables. So if we go up, so these are the variables which are being added in the Ansible playbook, but we can overwrite it using the -e, that is the extra variable. So for that, we can run the command. So let me come out of it, Ansible-playbook and the playbook name. And if we use the -e, that is for the extra variable. And if we want to update some name, so crt_common_name. And if we give name here, so it will update that. That is a Ansible variable precedence. So Ansible extra variable will override the variable which is being written in the Ansible playbook. Or if you want to go to the next level, use a Jinja tool loop to deploy multiple applications from a single list or YAML variable file. That's how platform engineers scale automation effortlessly. And if you want to learn Ansible from the scratch, I have a dedicated playlist for the same. I will add a link in the description. So I would suggest you to check it out so that you can get a better understanding of this particular demo. So that's it for today. With one Ansible playbook, we automated deployment creation, service setup, TLS key and the certificate generation, secret and the Ingress configuration, all repeatable, consistent and the production grade. This is how DevOps teams eliminate manual efforts and deliver application faster across environments. If you found this helpful, hit the like button, share it with your friends, subscribe for more content like this. Thanks for watching. I will see you in the next one.